We're going to talk about the idea of when we know a function is increasing or decreasing and something called the first derivative test. And the first thing that we need to do is we need to attach a definition to the words increasing and decreasing when it comes to a function. So far we've been kind of loose on our interpretation, but it is very helpful to have a very precise meaning. So, when can we say a function is increasing? A function is said to be increasing on an interval if for any numbers x1 and x2 on that interval, where x1 is less than x2, it implies that f of x1 is less than f of x2. So you imagine that we might have a function that has x-axis, y-axis, and as the function visually seems to go up as we go from left to right, we can say about this function that it looks like that when x1 is somewhere to the left of x2 along the x-axis, that f of x1 is less than f of x2. And this would be true for any x1 and x2 points that we chose within the interval over which this function was increasing. So this is called our increase. By definition, as long as x1 is to the left of x2 and it implies that f of x1 is less than f of x2, the function is increasing. Likewise, we could say that a function is decreasing on an interval for any two numbers where x1 is to the left of x2, f of x1 is greater than f of x2. And again, reverse this situation up here in green and you get the idea. Alright, so let's compare these two functions and just identify what this means. First of all, our function f of x squared plus 2. I have that right here in gray. So f of x, f prime of x, f of x, f of x is right here in gray. And it looks as though we could say that this function is going to be decreasing along an interval that looks like it might go from negative infinity all the way up to 0. Right? So if we were to pick any 2 points, x1 and x2, somewhere along this graph, we would see that the function of f of x1 is greater than the value of f of x2. Likewise, we can see that this is the kind of function that appears to include an increase over the entire interval starting at 0 and tending towards positive infinity, and it fits our definition above. All right, now compare that to the derivative of the function. The derivative here, f prime of x, is shown in purple below it, and f prime of x equals 2x. Well, what could we say? Well, anywhere where this function is decreasing, it looks like f prime of x, the value of the derivative, the y value of the derivative, is negative. And what's more, over this interval where the function appears to be increasing, it seems to correspond where values of f prime of x are above the x-axis. That is, where f prime of x is greater than 0. And of course, the only place where we have an interval right here, so f prime is less than 0 here, and f prime is greater than 0, it seems that at x equals 0, we have a special case where it looks like the slope of the line tangent to the curve is 0 and the derivative is equal to 0. F prime of 0 would be equal to 0 at that point, and we have this minimum. And this idea, this whole chain of reasoning, underlies what we call the first derivative test, which we will get to shortly.